In this video, we're going to go back and solve some more linear systems, but this time we're going to use matrices and technology, and it's going to go so much smoother and so much faster than the first time. Before we start though, I want you to remind yourself of what this was like. So I want you to solve this 3 by 3 system by hand, okay, using substitution or elimination. I would recommend elimination, okay, but do this with the video pause because I'm just going to work on the side and just pull in my answers and you'll see them in a couple seconds. All right, there it is. So, when solving a 3 by 3 system by hand, I'm always trying to look for, elimination because I like elimination. And I see this -5y, -5y, and +5y, and I decide, okay, I'm gonna just eliminate on y. So I add equation 1 to equation 3, add equation 2 to equation 3, stuff shakes out, I get x equals -2, y equals -3, z equals 3. Okay, but there's a faster way we could have done this using a calculator. Now watch this. So let's see, I'm just got a matrix in the calculator and I asked it to do this thing and I'm going to press enter and then it's going to just spit out those answers right there. -2, -3, 3. Okay, if this is something you might be interested in learning how to do, well, this is the video for you, right? Let me show you how to do this. So we're confronted with a linear system of equations and we're wanting to solve the system. And what we're going to do is we're going to do this by transforming an augmented matrix into reduced row echelon form. And you are not expected to know what those things mean. Okay, by the augmented matrix, that's kind of what I kind of quickly showed you on the calculator, that we take the coefficients of the system into a matrix, like I've got right there. And in this class, all you need to know is that a matrix is like a square grid of numbers. And then we're going to augment it like adding on to the side these extra numbers, what the equation equals 21, -24, and -21. Okay, I lost my vertical bar, but I was going to talk about that. That's really just there for your eye. Like, we're not going to be typing that in on the calculator. It's really just there to show you that, okay, 5x minus 4y plus 2z equals 21. Okay, so that's an augmented matrix right there. And then when we have the calculator do the RREF command, which is going to be like your best friend going forward. Okay, that's what it's doing, is it's reducing the matrix. And without getting too deep into the linear algebra of what's going on here, it's just doing elimination on the matrix. Okay, it's going to do all the same steps that you would do to solve this system by hand, except it's going to do it really fast. Okay, so we're going to ask the calculator to do RREF on this matrix, and it will give us back our answer. So let me show you how that works. So if we want to reduce a matrix, we're going to have to start by going into the matrix menu. And the matrix menu is right here, kind of below math. We have to access it from second. And we want to edit matrix A. So we're going to go over here and edit. And there is a slightly faster way to do this, and I'll show you that in a couple of minutes. But if you're working with a TI-83 or a TI-84 with the older operating system, you're going to need to do it this way. So we're going to edit matrix A. We're going to call for a 3 by 4 matrix. A matrix, oh no, not a 34 by 1. That would not be what we want. We want a 3 by 4 matrix, because that's a matrix that has 3 rows and 4 columns, kind of like the one you can see on screen. Okay, so we press enter, and it gives us, okay, a 3 by 4 matrix, and now we're going to type in all of those numbers. Figured you didn't need to watch me click in those numbers. It takes surprisingly long on the computer. So I've got that matrix. I'm kind of double checking it against the coefficients of the system to make sure that everything's right. Looks good to me. Okay, so we've got our matrix entered. So we're going to quit out to the main menu, and now we're going to ask for that RREF command. So we're going to go back to the matrix menu, go over to math, because we're going to have the calculator do some math. And then I think it's fastest to kind of scroll up to get to RREF. And then we're going to ask for RREF on matrix A. And this is where we're going to be using the names menu. Okay, we're going to ask for A just by pressing enter. We're going to have it do RREF on A, and then here we get ourselves a solution. So we're going to kind of just unpackage what this is saying here. So the first row, okay, this is 1x plus 0y plus 0z equaling 5. Well, that's just telling me that x equals 5. And then the second row is 0x plus 1y plus 0z equaling -1. And then the third row is telling me no x plus no y's plus 1z is equal to -4. But if you think about, whatever x or y or z is, if I multiply it by 0, it's just going to be 0. So these three equations in the colors here can kind of just boil down to x equals 5, y equals -1, and z equals -4. So, we've got ourselves a unique solution, kind of like I said was going to happen. And I think what I want you to take out of this is that if we go and we do RREF on the calculator, and we get this back, this 100010001 pattern, that's going to mean we have a unique solution. And I'll also show you what's going to happen, what it'll look like when we have no solution and when we have infinitely many solutions. But that's the unique solution scenario. Now let's look at one of those that has no solution. So I'm just going to tell you right off the bat, this system has no solution. And so we're going to start by transforming this system to an augmented matrix. We'll have the calculator reduce the matrix, and then I'll show you what we're going to see that'll let us know that there's definitely no solution. So let's start by copying down a coefficient matrix and augmenting it with the numbers that we see. So -8, +8, and -18. And I'm going to show you the kind of calculator shortcut here. So what we're going to do is if you have one of these nice like color addition models, we can just do this a little bit faster. We can start by calling for RREF. Okay. And in general, my recommendation is if you're going to have to use, the matrix edit menu, that you just clear the RAM every time. But I think when I go to do the infinitely many solutions case, I'll model that behavior. Okay, so RREF, we're going to just directly ask for a 3x4 matrix because F3 is like a matrix menu. So we're going to go select F3, and then we're going to ask for a 3x4. Okay, it defaults to 2x2, so you will probably on your calculator have to make that selection that's 3x4. Looks like I've solved one on this calculator recently using this technique. Okay, so I ask for the 3x4 matrix. I type in all the numbers, and then I can just press enter and have it do reduce row echelon form on that specific matrix right there. And this is pretty good. Okay, now, we see we've got decimals here. And, I think you might know already that this is -2/3. But if you get like a bad decimal, something you can do is you can just have the calculator turn the whole matrix into a matrix of fractions rather than decimals. So we'd go math, we'd choose frac, and we're going to press enter, and then we get ourselves a kind of a nicer looking matrix. So I'm going to copy this down over here and then make a little annotation. All right, so if I look at specifically the third row, what I'm seeing is 0x plus 0y plus 0z equals 1. And again, regardless of what x and y and z are, if I multiply them by 0, they're going to be 0. So I'm adding together 3 zeros, and this is like saying 0 equals 1, which we know means no solution. And how we're going to know that moving forward when we just go and reduce the matrix on our calculator is when we see that row at the bottom of all zeros and then a 1. That is what's going to lead us to conclude no solution. Now let's talk about infinitely many solutions. And this is the case that I had intentionally avoided, at the beginning of the course in September, or whenever that was, because this one can get a little bit more complicated. And I'm going to give you just a tiny bit of background on what's going on here before I go forward and solve the calculator systems. So we have a 3x3 system. What this really represents is 3 planes in space, and we're trying to figure out where they intersect. And what's oftentimes going to happen when they're not just all 3 the same plane, but we have infinitely many solutions, is that they intersect in a line. And it would look kind of like this, up to my drawing skills. We've got kind of 3 planes intersecting in a line. And without getting too much into the idea of 3D algebra, which is not the focus of this course, our solution space might be like a line in 3-dimensional space. And so I'm going to need to show you how to write the equation of a line in 3-dimensional space. But the preview is it's going to have one free variable. So let's enter this into our calculator and see what we're going to get. My recommendation is rather than overwriting the matrix that's already written in there, we're going to just clear the RAM to clear out that matrix. So we're going to press second plus 7, 1, 2, and it's going to reset the RAM for us. That's great. And so we go back into the matrix menu. We're going to edit matrix A. and we're going to ask for a 3 by 4. And in this class, we're pretty much always going to be asking for a 3 by 4 because I'm going to have you use technology to solve 3 by 3 systems, okay, which requires a 3 by 4 matrix. So I'm going to type in all of the coefficients, but maybe before I do that, I might point out that there's no y term right there. So I'm going to need to make sure to put 0y in where I would put, the number of y's in the third row. Okay, I've got that eraser. Okay, so let's copy in the coefficients. All right, got our coefficients copied in. We're going to quit out, ask for our REF by going to the math menu and scrolling up until we see our REF. We do not want REF. One R is not going to reduce it all the way, basically, is the fastest way for me to explain that. We want it fully reduced. So we're going to go over here, our REF on matrix A, press enter, and get ourselves a reduced matrix. So the thing that's telling me that I've got a system with infinitely many solutions out of this reduced matrix is the row of all zeros at the bottom. If you think about what that's actually saying, it's saying like 0x plus 0y plus 0z equals 0. And that's like 0 equals 0. One of these patently true statements was what we saw, in the past when we were solving a system and there was infinitely many solutions. I will throw it out there, though, like that it could happen that you reduced it and you got a row of all zeros and then another row that was all zeros and a 1, and that would still mean no solution, but that's not a scenario we're going to run into in this class at all. Okay, so we've got our infinitely many solutions, but we need to actually write down those solutions. Okay, just saying infinitely many solutions is not going to be enough in this class. Okay, we're going to have to actually find the solutions, find that line worth of solutions. And so I'm going to get rid of the calculator and show you how we're going to do that. Just like before, we're going to kind of translate these rows into equations. And I forgot to, say that I know that I've got infinitely many solutions based on that. So when we go to, translate from matrix to equation, we're going to have 1x plus 0y's plus 3z's equaling 6. And then from the second row, we're going to have 0x's plus 1y plus 4z equaling 6. And what we're going to do is we're going to, each time, if we're going to get infinitely many solutions and we're reducing with a calculator, it's going to be z that'll be the independent variable. And again, I don't want to get too much into the theory of basically it's linear algebra, but we're going to solve for x and y in terms of z, and we're going to let z be the independent variable. So we're going to go and just, on both of these equations, solve for x and y by getting rid of the z on the left side. So I'm going to subtract 3z from both sides. So I'd have negative 3z plus 6. And then with y, I'd subtract the 4z from both sides, and I'd have y equals negative 4z plus 6. And then, z is just going to be able to be whatever it wants. It's an independent variable. It's a free variable, like I was saying we'd see in the line in space. Okay. And, if you want to kind of stop here and say this is my solution, this is a decent way to write the equation of a line in space, especially, as an Algebra 2 student. But if you want to take it a little farther and write it, the way that most people would write an equation for a line in space, we'd write our answer as a vector as well. So our answer is going to look like this. Okay, it's going to be a vector, which is a column, it's a single column matrix. And so we would go in and we'd say, all right, usually we let t be the independent variable in situations like these, doing three-dimensional algebra, writing the equation of a line in space. So I might say negative 3t plus 6. Y would be negative 4t plus 6, and z would be t, that independent variable. Okay, so really either of these things, either of these ways would be a suitable way to display your answer. And I'll warn you right now, infinitely many solutions, it requires significantly more work than the other two. With no solution, you see that row of all zeros and a 1 at the end, we just say no solution. With a unique solution, we just read the solution right off that last row. But with infinitely many solutions, we have to do a little bit of extra work. So that's probably going to be the one you need to practice more than the rest. But hopefully, you do a few of these on the calculator and you're like, okay, I can do this. And this is much faster and much more reliable than solving these 3x3 systems by hand, especially if the solutions are not going to be integers. Okay. I think that's going to be all I've got for you in this video. Yeah, I did one of each type and don't want this to go on too long. So that's going to be all. Thanks for watching.